A very good afternoon to one and all present here. Honorable Padma Shri Dr. Kota Harinarayan Sir, Director CSIR IMMT Dr. Ramanuj Narayan Sir, Professor Damodar Acharya, former IIT Director Kharagpur and Chairman INAE Bhubaneswar Chapter, Professor Subhranshu Ranjan Samantray Sir, dignitaries, scientists, permanent staffs, students and contractual staffs, a very warm welcome to the celebration of National Technology Day 2025, jointly organized by CSIR IMMT, INAE and INAE Bhubaneswar Chapter. I request everyone to kindly stand for IMMT theme song. Thank you, everyone. Over the years, National Technology Day has evolved into a flagship occasion for honoring scientific excellence, showcasing industrial innovations, and reinforcing the partnership between science, society, and industry. This day commemorates the momentous events of 11th of May 1998, when India conducted its successful nuclear tests under Operation Shakti and saw the maiden flight of indigenously developed Hansa-3 aircraft. In recognition of these achievements, then Prime Minister Shri Atal Bihari Vajpayee ji declared 11th of May as National Technology Day. To mark the auspicious beginning of today's event, we invite our Chief Guest Padma Shri Dr. Kota Harinarayan Sir, Director CSIR IMMT Dr. Ramanuj Narayan Sir, Professor Damodar Acharya Sir, Professor Subhranshu Ranjan Samantray Sir, Dr. Mamta Mahapatra Ma'am, Dr. Vikas Kumar Jena Sir, for lighting of the ceremonial lamp symbolizing knowledge, innovation and enlightenment.
शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते दीपज्योतिः परब्रह्म दीपज्योतिर्जनार्दनः दीपज्योतिर्परब्रह्म दीपज्योतिर्जनार्दनः दीपो हरतु मे पापं सन्ध्यादीपनमोऽस्तुते ओ दीपब्रह्मरूपस्त्वं ज्योतिषां प्रभुरव्ययः ओ दीपब्रह्मरूपस्त्वं ज्योतिषां प्रभुरव्ययः आरोग्यं देहि पुत्रांश्च गतिं स्वच्छां हि मे सदा रवेरस्तं समारभ्य यावत् सूर्योदयो भवेत् रवेरस्तं समारभ्य
नेशनल चैंपियन माताड्तैते
सूर्योदयो भवेत् यस्य तिष्ठे गृहे दीपः तस्य नास्ति दरिद्रता शुभं कुरु
I request our director, sir, to welcome our guests with flower bouquet. Now I take the privilege of inviting Director CSIR IMMT, Dr. Ramanuj Narayan sir, to deliver the formal welcome address and set the tone for today's celebrations. So please.
जय जगन्नाथ, जय जगन्नाथ, जय जगन्नाथ. On the dais, the most respected, well known, the most famous duet is there. Okay? Padma Shri Dr. Kota Harinarayana sir, Professor Damodar Acharya sir, my friend from IIT, and who is a young person who is trying to do very good work through Academy of Engineering, Samantraji, my young colleague Dr. Vikas Jaina, Dr. Mamta Mahapatra, all the members of INAE, all the...
Can you unmute? We are not able to hear.
All the members of INAE who are here and also joined online, all my senior superannuated colleagues, all the family members of CSIR, IMMT. Today we are here. I think when Professor Acharya had ordered me, it's a ordered means request, that we respect him. He is an institution builder. He told that I want to celebrate National Technology Day in a style, in a unique way, at the 4 places across the Bhubaneswar city, and one of the venue selected is IMMT. It's an honor for us, sir, to follow the that whatever advice you have given. Then the second pack was who is going to deliver the lecture. Then he also selected with design, none other than Padma Shri Kota. I was not knowing he is a fortune teller also, because what Tejas, what aircraft design, what type of technology Professor Kota has developed, that has shown in recent 3 days. Okay, so we are on the backdrop of it. The National Technology Day is being celebrated for our Pokhran, but now this year onwards, we must remember the great contribution of all our aerospace, DRDO, and all the related scientists who has helped us in making the missile. And today, BrahMos is doing the round. If you are in a WhatsApp university, or you are outside the WhatsApp university, but खम ठोक टेलता है जब नर पत्थर के जाते पांव उखड़, मानव जब जोड़ लगाता है पत्थर पानी बन जाता है. With that determination, the country which was not having their own weapons and those type of system, the person like Kota Harinaran, our former president, and many more, that ISRO, that start from, I cannot name, Madhavan Nair to our Dhawan to everybody. Vikram Sarabhai, Homi Jahangir Bhabha. We are a proud nation, and what vision they have shown, today we have shown that we are the world beaters. Only बजरंग बली को अपना शक्ति याद रखना चाहिए. We have to remember, we are there, and you know, Technology Day, the name and theme whatever selected, yantra. If you go inside the yantra, there is a message for all of us. There is a strength you have to learn if you want to grow in science. You have to build the things whatever has been done in the past. You have to put on the shoulders that our heritage is like that. If we'll go for yantra, starting from our Jyotish till today, Pushpak Biman, it may be a dream, it may be a story, but it has come to reality. I don't want to put myself in a thought, but yes, there is a learning, and that learning has given us the world beating organization, whether it is a ISRO, whether it is a BARC, whether it is a DRDO, whether it is CSIR, whether it is ICMR, whether it is ICAR, collectively, or beside that, the IITs, NITs, ICERs, all the colleges, all the educational institutions. This has made us proud. Tomorrow, Silicon Valley we talk, it's India. If AI will talk today, what topic Harinarayana sir has selected, you see, learning never ends. And today, he will exemplify that he is going to talk on AI. When he started his system, that time he was not operating computer also. Only some calculation things used to come, big computer of one room size. Slide rules. But today, he is going to deliver lecture on AU. My friends, whoever are here or online, these are the learning. We have to respect our senior people, that what legacy they have left, what knowledge they have left, what analysis they have left. And you can see two of them. A great inspiration the day I came to Odisha, the Professor Acharya. The type of suggestions he gives, the type of vision he has, that's why Kharagpur has gone to that level. And I know, son of the soil. You see, one is a Brahmpur Naresh. Okay? Just see connection, that line connection, that has brought back to that. If India has to be Viksit, Odisha has to be Viksit, and we have two stalwarts. One person is educating, pumping the education, another person is pumping the technology. And then, you see, in this age, I am thinking of INE, Indian National Academy of Engineering, that how it should go. We are very fortunate, sir, that last year we have taken part in the annual convention, that what was organized under your chairmanship, and we have seen the type of things, whatever we have done, and all of you who have taken part, you can see the type of deliberation, the type of fellowship which has been selected, the type of leadership which has been provided. So once again, if I will go on and on, it will be very difficult. So I will restrict myself, once again, I am grateful, sir, for selecting IMMT as the venue. Very grateful to you, sir, because I want to listen. I can talk a book on you. I have studied about you. So what activities you have done in made you proud, and let us take pride. These are the person due to which we have. I will not tell. We are the front runner in battle, because today's battle there is no defeat, there is no win. It is the upper hand, and our country was in upper hand with our neighbors. So the contribution has come from scientific technology fraternity, and this is the right time to celebrate the Technology Day. And all of you sitting here in some form or the other, you are putting the efforts for developing technology. You are material. That material will be required for aerospace. That will be required for the energy. And let us work together as a collaborative manner. Our country has shown the power, but more power is sitting in the younger power of the country, the research scholar, the students. Each one of you have to contribute 2047, what our Prime Minister, our Science Technology Minister is looking for, that will be fulfilled through that dream. So with this, once again, I thank you all. Vande Utkal Janni, Jai Hind.
Thank you, sir. Now I request Professor Subhranshu Ranjan Samantray, Head School of Electrical and Computer Sciences at IIT Bhubaneswar, Odisha, and Fellow of Indian National Academy of Engineering, to brief us about INAE and INAE Bhubaneswar chapter.
A very good afternoon to distinguished dignitaries on the dais and up the dais. Today's attraction, Dr. Kota Harinarayan, one of the eminent scientist, engineer, designer of this country. So as has been discussed, the man who has really contributed to this aircraft technology, and so Professor Damodar Acharya, the chairman of INA Bhubaneswar chapter, and president of advisory committee of SO University, Dr. Ramanuj, the director of this institute. We have Dr. Jena, the coordinator, and Dr. Mahapatra, another coordinator of this function. We have eminent fellows, Professor A.K. Tripathi, former Director General of CPRI Bangalore, Professor U.C. Mahanti, one of the eminent person of this country on the Earth, Ocean and Atmospheric Sciences, and the Bhatnagar Awardee of, I think, the first Bhatnagar Awardee of this country in this domain. We have Professor P.K. Mishra, one of the eminent scientist and professor, lastly retired from IIT Kharagpur. All the scientists over here, maybe faculty members from organizations, ladies and gentlemen. So I welcome you all to this august occasion of INA Technology Day celebration 2025. So to begin with, I will throw some lights on INA, Indian National Academy of Engineering, the apex body of engineering of this country, established in 1987, 38 years back, which includes most of the distinguished engineers, scientists, technologists, covering large spectrum of all engineering sections, working for solving problems of humankind, reaching society, and meeting the problems of national importance. So Academy also provides forum for futuristic planning for the country's development, requiring engineering and technological inputs, and bringing together the specialists from different fields which are necessary for comprehensive solution to the need of the country. Now, INA has different verticals. If you look at INA is engaged, there are three major segments. One is knowledge creation, knowledge dissemination, and knowledge translation. So if these are the three verticals, possibly INA is looking at all the three verticals, and the people who are engaged, they are eminent experts in different fields, looking forward to solving different problems. One of the major recognition INA gives is or recognizes people is INA fellowship. So if you look at today's scenario, INA has almost 1,000 fellows who are staying inside India and another 100 foreign fellows. So INA also recognizes people who are working abroad, may not be origin of Indian, but they have contributed to Indian context. So that is how INA is spearheading, and last 38 years it has gone through. INA also identifies young fellows, young associates who are at the age of 35, just to recognize the people who can really ignite the systems. And recently they have also included something called membership of different cadres like associate and senior membership. So this is how INA has a big spread over this country and abroad to show the quality of life, to enrich the life in humankind, and the technology for humankind, which is really the need of the day. So looking forward to further creating an dissemination platform, or so-called new knowledge dissemination platform at the local level, INA has opened almost 10 chapters. So it's starting from the Pune, Bangalore, Delhi, I think Chennai, Kharagpur also is there. So like that, Bhubaneswar chapter started in the year of 2021 under the able leadership of Professor Acharya. Then the fellows who are staying inside this state or outside, they are connected, and we built this forum. And this is doing very well and has been identified as one of the very active INA society chapter of this country. That is the reason this year they have awarded this Technology Day celebration to INA Bhubaneswar chapter, and this is one of the venue. Thank you very much for being part of this and giving us the place to observe the National Technology Day here. Now this chapter is engaged in various activities, and one of the achievement is our chapter has conducted almost more than 60 keynotes within this time, which is a big achievement. Drawing eminent persons from this country, drawing eminent scientists and technologists to really disseminate new knowledge in different domains. So that is how INA is engaged the experts. If you look at the technology and innovation, right now, starting from the energy, starting from the artificial intelligence, you look for materials, you look forward biotechnology, and if you go to computing and the quantum, all are coming together to serve the humankind. So we must thank INA to bring such a big forum and of knowledge dissemination as well as technology translations. I will not speak much more. Again, I welcome you all to this Technology Day celebration at IMMT, one of the venue here out of the 4 which we have selected to conduct in this city. And I strongly believe the takeaway from this talk will be having a good footprint. Thank you very much. Have a wonderful day.
Thank you, sir. Now I request Dr. Vikas Kumar Jena, Senior Principal Scientist, Department of Material Chemistry and Interfacial Engineering, CSR IMMT, to introduce our chief guest.
Good afternoon to all of you. So at the outset, the dignitaries on the dais and of the dais, my dear colleagues and students. So really it is a great honor and privilege for me being stand here and say a few things about Dr. Kota Harinarayan. So Dr. Kota Harinarayan hails from Berhampur, Odisha. He did his studies at IIT BHU, IIC Bangalore and IIT Mumbai. He is an acclaimed aircraft designer. In his illustrious career of almost 5 decades, he has held responsible positions covering entire gamuts of aircraft life cycle. His experience includes upgradation of fighters, integration of new weapons, certification and design of supersonic fighters, transport of aircraft, and unmanned air vehicles. He has led many complex and technological challenging aeronautical programs. As program director and chief designer of India's light combat aircraft Tejas, he successfully directed the project and developed first of its kind aerospace ecosystem in the country. Thanks to his effort, India succeeded in developing a state-of-art high technology fighter aircraft of world class. He was Vice Chancellor of Hyderabad Central University, visiting professor of IIC Bangalore, IIT Mumbai, and also DS Kothari, DRDO Chair Professor at ADA. Also INAE Distinguished Professor and SCRB Distinguished Fellow at CSRNL. He was President of Aeronautical Society of India and founder chairman of Design Division of Aeronautical Society of India. He is one of the founder of General Aeronautics, a startup incubated by IIC Bangalore. He is at present the chairman board of governors of IIT BHU. With his outstanding contribution to Indian aeronautics, he was honored with Padma Shri by the Government of India in 2002. So with this brief introduction, so now I request sir, to now the podium is yours, sir.
This is forward, no? This is forward. Professor Damodar Acharya, Dr. Ramanujam, and I'm seeing a lot of my friends, colleagues and all here. And I feel happy to be here because a few months back I was here on 1 week, are you able to hear me? Mm-hmm. 1 week, 1 lab program. I came here. So I never thought in next few months I'm going to be here again and then meet a lot of my friends who have met them earlier. So it was a pleasure to be here. And thanks to Dr. Jana and Dr. Mamta for taking care of me. And I had a good visit of some of their facilities today. And I'm looking forward to India becoming not an importer but exporter of rare earth materials and critical minerals. And where else it can happen except IMMT taking the lead, okay? So that's what I thought. It's a beautiful thing to have. I was just wondering what should I talk. I thought, let me talk to you because India was in service sector for a long time, doing quite well. But today we were talking of manufacturing. Now we talk about design, development of products. If India has to stand its own legs, we have to develop products, we have to develop system of systems. And whatever we have developed in the recent, 4-day war, they proved themselves quite well, okay? So, but this is a moving target. We have to continue to work hard, continue to strive, continue to be ahead of the competition. So I thought the topic, which is quite known now, the artificial intelligence. But I thought this is also the technology which is required for designing product and aircraft and all. So today I thought, let me talk about that, because I feel this is the technology we need to use more and more, so that we become world leaders in developing systems and product systems and all. Okay, it's a very powerful tool. I'm fascinated by it. Let me, at this age, I'm very, very fascinated by this. The more I look at it, the more I feel that I should have been younger, so that I could have gone more deep into the subject. I had met some of my colleagues from University of Hyderabad. Madam, are you here? Yeah. So I just joined the University of Hyderabad in 2002, and I saw one center for AI there. You have to give credit to the people. They had a center for AI there in 2000, and it was there for a long time before I landed there. I didn't find many people there. It wasn't a favorite subject. And today, it is a subject from a school boy to the Prime Minister of India. That is the kind of change that has occurred, which is in the right direction. So I chose aircraft design because that is the field mine, but it's equally applicable for any design activity we are going to do. So let me now go through. I also want to say that the way the INE Bhubaneswar, thanks to leadership of Professor Damodar Acharya, is doing in Bhubaneswar, it is really great. Because I, as often as possible, I listen to all the lectures that you organize, and he put me in the Bhubaneswar chapter. So I'm part of Bhubaneswar chapter. So that's how I listen to all the talks and all. And I have not seen any other chapter doing even 1/4 of the work what you are doing. Because I'm in Bangalore, we do something, but nowhere near what you are doing. So I want to compliment you, and it's really a great job which all of you are doing. So now let me start boring you. I just thought to start with this slide, because it's a fundamental slide, but that is what is there. Most important thing is, you use computer science, robust data to problem solving. See, any design, any activity is problem solving. Any engineering job is problem solving. If you can't solve problems, you are not an engineer. Okay? So we started with artificial intelligence, where you try to mimic human intelligence. Then in the last few years, the machine learning, which is a subset of artificial intelligence, where you train machine to learn using statistical methods. But another very beautiful subset of that is the deep learning, okay? Where you train machine to learn rules using several multiple layer of neural networks. It's exactly the way our brain works. We have a series of neural networks, and our brain goes through all the neuron filters, and then very complex thing, it is able to do that, okay? And that is exactly what. If you see the old, all of me, including me, we all are learned. We have rules, we have an approach, we got the data. Now, you have data, you have AI approach, you have rules, and you predict new data. I thought it's a very simple one, but this is what it encompasses the key elements of AI. I'm not going to talk anymore of that one. I thought if I look at it, if you go to AI Pilot or anybody, he will show what all areas it can be used in aircraft design. One is the shaping of the aircraft. We use a computational fluid dynamics to shape, aerodynamics, structural design, material selection, performance optimization, noise reduction, system integration, autonomous system control, health monitoring, and prognostic. Today, with that AI, you can't do this. It's a very critical thing. And pilot assistant, you have heard of unmanned aircraft and all that. One of the key element is you call a co-pilot. Today, I think Google calls it a co-pilot or something like that. Okay, you have a pilot which is so loaded, I will show you some slide, that he needs some assistant. Then he will do an efficient job. I'm going to talk about that. The environmental impact and sustainability. use this one. Then urban air mobility, I'm hoping in a few years we'll have a small aircraft which can take off land from center of the city to the airport and all other things. And AI in agricultural aviation. I think still in Odisha, a large percentage of our what you call gross state productivity comes from agriculture. We still have much higher, okay? And at least 50% of the manpower is still used in agriculture. And we have to see how to make it more efficient. In India, also in agriculture, we use 50% of the people, are the same as in agriculture. And it is an area where there is a need for substantial improvement. Otherwise, you are going to import food grains, which is not what you should do. We are the largest population in the world. You need to show how to improve your productivity. Your land is not going to increase. We have to improve productivity 3 times. That's what we should do. So I will start with bottom. AI in agriculture. Okay, that's what I do. So AI in agricultural aviation, that is I think it's an important area. The government of India has given a lot of importance to that, and there's something like a revolution is occurring. I just want you to have a look at it. Roughly 17% of India's GDP comes from agriculture. Small variation can be there year to year. 50% of our manpower is used in agriculture today. 22% of our electricity consumption is for agriculture. 29% in peak time. And groundwater upstream, 80% of the groundwater is removed for agriculture purpose. Okay? That is the kind of scenario. You could see the overriding role of agriculture. And if you want to put technology, I think agriculture is the number one where this technology should come. Now let us look at the productivity. I'm not comparing it with Israel and all that. I'm comparing a country like China, which in 1949 was today has 4 times our economy. I'm just looking at soybean, sugar, maize, rice. Rice is a major product here, all of them. The average for India, what you call India, average for China, you can see our water consumption is 2 to 3 times, but our output is not even half. So this is a major thing. We are using water. It's not only water. We use more water, more fertilizer, more pesticide, everything more. But output is low. This is something, we are all engineers, we should worry why it is so. That is what I thought is important. And interestingly, if you see some of the southern portion on the top, the water table is coming down year after year to an alarming level. Some of the states like Tamil Nadu, it has come in last 10 years, it come down by 80%. You don't have water to extract. That is the serious scenario where we are. Okay? So what are the issues? Scarcity of water, low crop yield, inadequate crop quality. An average, what you call rice you eat, there is more pesticide in it. Only we are able to, because from childhood we are eating the same rice, so we are able to withstand. If some new fellow comes, he will reach headquarters fast. So excess application of water, fertilizer, pesticides, rapid change. Now what is happening is, earlier, there is a day on which you will sow. There is a day on which we will do things. And weather was more or less predictable. It happened that way. Today it's not. Just total change in weather, total change in environment, and with all the so-called support being given, most of the farmers are still indebted. If I talk to any of my friends who are still in farming, they say 1 year it may be good, but next 4 years they are in bad shape. Sometimes people say, no, they don't have to pay income tax. You should have income to pay tax, na? That is the problem. That is where we are. So it is a serious problem where we are. Now, what is the technology inversion? The technology inversion is precision agriculture. There is no doubt. And that is what it does. It prepares the land. It prepares the land for farming, ensures equally fertile across the field, monitors plantations during in-season growth, detects early onset of pests and diseases, ensures application for input in right amount, at right time, at right location through harvest and post-harvest processes. What it involves? Remote sensing, use of geographical information system, and global positioning system. Now Navic has come, we can use that. Instead of GPS, we can do that. So image processing, am I able to see? Yeah. Image processing to determine soil nutrient, composition, early detection of pests and diseases, application of farm input like fertilizer, herbicide, water, and all these things. That is where we need. So what is the heart of this one? Let me put to you what is happening now in the world. And I'm happy the government of India has put in tremendous amount of support this program. So basically what is that precision agriculture, real-time data. The real-time is important. Predictive analytics. Before a disease spreads, you identify the disease and you kill the disease. That is the key point, the predictive analytics. And the fellow who is able to do all that are the drones. But the heart for all these things is the predictive analytics. And that comes from AI. Okay? That's what it happened. So, to precision agriculture aviation for remote sensing, artificial technologies for data analysis and interpretation. Both are required. If you have artificial, you can do, but manually if you do, there is a limitation. But if you use an unmanned vehicle, you can do it pretty well. And today, the cost has come down to such a level, actually, and even the government is giving a lot of subsidy. It is cheaper than doing manually. That is the situation where we are. What are the remote sensing? It is one of the key elements. One is the satellite base, another aircraft, third is UAV. The satellite base is good. We have many satellites going on. But the problem of satellite base is that information comes to some location, that fellow will consolidate, then it will go to some state, that fellow will consolidate, then it will come to the farmer. It may take some 2 weeks, 3 weeks and all. By the time the disease has spread so much, there is no need to do any job. Khatam ho gaya sab kuch. So you need to do something. Otherwise, that is good. So aircraft is in near real time can do, but so expensive. Can you ask for an aircraft to do in my farm of 10 acres? I can't do that, okay? But with a UAV, you can do that. Today you have seen even marriage parties, there is a drone going. So there is no problem. It is cheap, it is available. The problem is, how do we use this UAV? When you surveyed, how do you convert the data for for applying all these kind of things? And that is where artificial intelligence becomes a problem. So what is image processing? It traditionally is image pre-processing, image segmentation, feature extraction, image classification. Cumbersome, time-consuming, cost is very high. And it will take months. So that's what, when I went to the AI center in University Hyderabad, they were doing all this. It was quite a time-consuming, expensive thing to do that. Okay, but with the advantage of AI, image processing, the drone, what happens is, you use a simple RGB camera. Not hyperspectral or multispectral, nothing is required. Just a simple RGB camera. Today that camera is available in, I think, 1,000 rupees, 1,500 rupees also good enough for you. It will fly, a drone will carry the camera. It will fly up 20 meters above land, just about that. And it will take the pictures. And it lands after about 15 minutes, 20 minutes. Offline you process. In a matter of 1 hour, the complete data is available. You use the AI technique to quickly process that, and that is where the algorithm begins. And you don't even need a multispectral or a hyperspectral, because they cost about 1 lakh, 2 lakhs, 5 lakhs. Even a hyperspectral can cost 50 lakhs also. This will cost some 2,000 rupees. So you can see, I just want to show you something. You can see the nitrogen deficiency in a paddy, productivity variation in paddy, poor tailoring in paddy, productive variation. These are all the pictures from India. Not a single picture from abroad. This is all in Indian, okay? Actually, at IIIT Bangalore, Professor Nilima, she had done a fantastic job along with other group of people. I am showing some of their pictures. Okay, this is what Neelam Sinha has done. There is a institute for plantation research, about 100 years old, very good data. But you know, coconut plant is 150 feet high. Who can go and check whether it is okay or not? But a drone can do that. So the knowledge gained by these people with the drone and with the computer science, when you put them together, you get a wonderful technology. And they could do all that in a matter of 6 months. Okay, I thought it's a great job the team has done. And the other thing is, as I rightly said, the hyperspectral cameras, multispectral are expensive. But Professor Santanu Chaudhary is no longer with IIT Jodhpur. I think he has gone back to IIT in Delhi, back again. But when this was, he is there now. You use a RGB camera, but it will do the job of a hyperspectral camera. It's a very beautiful job. Technology he has done. A smartphone, a dedicated device, that's what he says. And the trick is use of deep learning. The trick is use of deep learning. Okay, that is the fellow which makes a simple RGB camera costing a couple of thousand rupees to do the job of a hyperspectral camera, which will cost you a few lakhs. And that is what he had done. And he has come out with a beautiful equation. You can see that, simple fellow, but he's doing job. And we have applied this for all of some of the cases. Works well, works well. If suppose, I remember many years back when I was at University of Hyderabad, we started a center in a place about 100 kilometers away from Hyderabad. And one of the big problems in that village was the farmers didn't know how to know the seed that is given at the buy is a good seed or not. By the time you come to know all that is there. So it used to be always a problem. Always a problem. We had an agriculture scientist who was getting from a reliable source and all. But how do you know? Now this technology, CNN technology, you can clearly find out, is it a good seed or not? Which is an important thing for a farmer. Which is a very, very important thing for a farmer. Okay? So seed, actually the Center for Engineering Research, they have done a lot of good work. I've seen their work. And it is good, but the point is how to bring it to the farmer, and that is what we are able to do now. I thought this is a mango season, so I must tell you something about mangoes. I have a colleague called Onkar from Indian Institute of Science. He has done a lot of work. How to, see the problem of mango is, if you pluck it early, it will not would have ripened well, okay? If you pluck it late, rainy season and all, it will get spoiled. So pluck it at the right time, okay? That Baiganapalli and all what you do, it is very good provided the right kind of maturity is there. So you have done some algorithms here, detected mangoes. First you have to detect the mangoes. Because the fellow who is now selling the mangoes should know how much mangoes are there which can be done. Then he does a convolution neural network work, okay? And he does the post-processing and mango detection. He can precisely find out how many mangoes are ready for what you call plucking. Okay, this is what is done. Then what is the method? I am going to give you a little detailed one. Pre-processing, patch generation, mango net. He has a technology called mango net, semantic patches, the usual language, and then you come out with the things which need to be done. So it has now become, it is being used by many farmers in Innan and Aro, Bangalore. Okay, he's a very favorite man for mango growers. Okay, because he's getting profit for them. That's what. Now, you may be wondering why so much. As I said, 30 years back, 40 years back also, AI was there. But the point today is a convergent algorithmic advances, data proliferation, and tremendous increase in computing power and storage. That is what the hype has become reality. The cost of computing has come down, and the process power has increased in orders of magnitude high. Okay, when we were starting our aircraft program, we bought an IBM 3090 computer. For that, the Prime Minister of India had to talk to the President of United States to get a license to get the IBM computer for work in our LCA project. It was a big checker, okay? And half of our building was occupied by this mainframe computer. Half the building was occupied by that. Today, I think my mobile has more power than that fellow. That is the kind of thing. So you can see the kind of there. And mobile has more apps, more power, more things. Okay, and it doesn't need air conditioning. So that is the level of increase in power, and beautiful algorithmic developments have occurred in case of AI technology. And of course, we have data. Today, thanks to the digital life, data is available. So that is what it makes it okay. I want to give a next example, which is very important, whether you are doing an aircraft, you are doing any machinery, anything. This is a very critical technology. We must master it. I hope engineering colleges are teaching. If they don't teach, they are not doing justice to their students. I want to tell you that. Okay? What it does is, in case of an aircraft, you have seen recently a war, I don't have to tell you now. Sometimes we ground an aircraft for maintenance. And we'll say every 150 hours aircraft should be grounded for 2 weeks. So on those 2 weeks is not available. Not that system has failed, but that is the way they say, before a failure occurs, I must do that. What you call advanced maintenance. So it's a big checker. I'm sure in machinery and everything we do the same thing. In the shop floor also we do that. You down the machine. And when you down the machine, that machine is connected with half a dozen other machines. The whole shop comes to some kind of a semi condition where you are not working efficiently. If we have a way whereby I can detect in advance when a failure occurs, okay, I can then plan early. And I get an information, at least a week in advance, I can do that. And that is what health monitoring system, it does that. It reduces the downtime. And see, today in an aircraft, we have 4 redundancies. If 1 fails, 3 will work. 3 fail, 2 will work. 2 fail, 1 will work. All that because I don't know when it will fail. I don't know. Okay? If I know, I don't need all that 4. I can finish it with 2. Okay? That is the point. And need for all these UAVs and all that kind of, we can see that. If you see that, we have, this is the technology we are using in light combat aircraft, okay? The structure, we have a monitoring system, and initially we spend time to calibrate our algorithms, okay? And try to see when the structure is going to fail, and whether the failure is genuine or is a false. That also you have to find out. I think a lot of work has been done. Today the accuracy levels are of the order of 99%, which seems to be good. Okay? We have come to a fairly good mature level for the structure. We also do something similar for an aircraft gearbox. Aircraft gearbox is the one who connects the engine with the aircraft. If this fellow fails, the engine is disconnected, the aircraft can't fly. It's a very critical, safety critical point. And it is a mechanical system. It has a shaft, it can be a shaft misalignment, bearing failure, gear to damage, oil contamination, loss of lubrication, filter clogging, it can be anything. Now, how do I know what failure has occurred and what has led to that failure, which is the cause? And that is what the health monitoring algorithm will be. But from the type of failure, type of symptoms you get, you will be able to know what is. Is it a bearing problem, oil contamination problem, filter clogging problem, or shaft misalignment problem? It can find out. And with that, you are able to now, you can also tell you in next 3 months or next 1 month, this failure will occur in so and so part. So that is a fantastic information. It doesn't matter if it's mechanical. I've shown it as an example gearbox. It can happen to a motor. It can happen to any other part. It is basically, this is the technology. And this technology, it will predict now how it is going to happen, when it is going to happen. That is the point. This is very, very important technology. I'm happy to say this technology we are now using for the aircraft. And then we have actuators, servo actuators. Today, the whole aircraft and most of the systems are all servo systems. And interestingly, this is the actuator which was developed in India. In 1998, we are talking about that India has exploded an atom bomb. The Americans have thrown us out. So all this actuator gifts which we were buying, they said we will not give you. We felt very happy about that because if they don't give, our fellows will work. Otherwise, we are happily importing everything. Okay? We are the only people who are happy to import. So that is the thing. We have developed this now. the modeling work was done, in fact, we were done in the old Bengal Engineering College. I think now it's called Indian Institute for Science, Education and Technology, IIS, SCTI, something like that. Is it not? That is what. They have done a lot of good modeling work. Jadavpur University has also done. And the previous one, a lot of work was done at IIT Kharagpur. Okay, a lot of work was done. So you, what you call the sensors, how do you do the sensor? If I'm sensing something, first I should know the sensor is working correctly. So how do you do the anomaly detection sensor? That is what we need to do. And that is where a lot of work has been done, it's still going on. Okay, and this is a beautiful technology. It gives you can see the convolutional neural network thing, CNN. And this is what you are using here. This is convolutional. And input image you goes. Then one set of data is taken by the neurons. Now next set I will go to more refined, more refined, more refined. At the end, you have a very fine detail about what is happening. Okay, this is what is there. You see, sometimes I don't have sensors. Quite often I can't put so many sensors. So virtual sensing. This is what I was telling about heat exchanger temperature prediction. This is where IIT Kharagpur team has worked. We were able to, just from indirect data, we are able to synthesize the so-called sensor and then able to find out what is the temperature. If the temperature reduction is not occurring, that means there is a problem and you move forward. Okay? This is what is happening. So AI is a vital element of aircraft health management, especially in diagnostics and prognosis. It enhances safety, reduces downtime, reduces maintenance, reduces operation cost, and higher availability. What I'm talking today for the aircraft is equally valid for any ground workshop or any automobile and everything. In fact, most of the automobiles today have got some element of health monitoring. Some element, may not be very extensive. So this is the kind of thing I genuinely feel every student must be taught in the academic institution, and everybody should be given the training how to do that one, and that will become, he will go with that knowledge when he goes to an industry, which is very important, okay? And irrespective of the electrical, mechanical, civil, anything, all of them, it is equally valuable. Now, I thought let me talk about my favorite subject of aerodynamics. How do you shape the aircraft? How do you do that? Because you know, an aircraft is as good as the shape and the size, okay? And this shape is very, very important, and the very detailed things what we do. So this is where, again, this technology has been used to the extent. I have a young colleague called Prakash Raj in ADA, and he and his team have done pretty good work. I want to show you some colorful, my colleagues used to say CFD means colorful drama. Okay, but the drama is quite interesting. See, normally what we do, we make a shape, and then we find what is the pressure that is there. And we say, if this is the pressure, the drag will be less, fuel consumption less, and that is how you design that, okay? But now, if there is a way, I give the pressure on the top, bottom, I said, I want an aerofoil shape, or wing. I've shown aerofoil, but you can go to the wing and all. That will be beautiful, okay? And that is the technology, the convolutional and neural network does that. I give this and it does that, okay? A lot of interesting work is still going on. So what do? You combine the convolutional network with the neural network, you combine that encoder and decoder, you put them together, and what you get out is a shape of the thing. I showed an airfoil, you can do for a wing and all that kind of thing. And that is exactly what is going on. Tremendous amount of work is going on in this direction. And we must master them, okay? We must master them. Some people are doing, but we have to see how to make it mainstream, okay? You can see this one. How inverse aerofoil you convert neural net, how this happens, okay? It continuously varies and comes with a, what you call optimum shape and size and all that. Some more. We've taken the standard NACA aerofoil. This is what you do, even for fans and all also, we use NACA aerofoil to do that. And you now see if this is input, what is the output and all. And by training data set, you'll be able to now simulate it and then find out how good it is. Because data is most important, okay? The old story about GIGO, garbage in, garbage out is still applicable available here also. So you need to see how to get reliable data. You can see that with the training that I have given, the prediction becomes very good. But training is very important, and training with the right data. So that is the key, okay? That is the key. I want to show this one. If you see carefully, there is an intake for the aircraft. And this intake is shielded. It is on purpose. The shielding improves the, what you call, stealth property of the aircraft. In fact, it is the smallest fighter in the world. And even without doing anything, it is highly stealthy. Okay? It is something like 1/100th of a normal aircraft, it is there. But we can do further. With her, we are working on how to improve the stealth properties and all. Okay? But then, this fellow, this intake, if the flow is distorted, then the thrust developed will come down. And the thrust developed will come down, the aircraft maneuverability will come down. How do you design such that distortion is minimum? Okay? Without asking the intake to come out. Because if it comes out, it will do well. But then you lose your stealth property. That is basically the kind of thing what we are doing. Very interesting work these young people have done. Okay? The CFD data, then do experimental data, then they did lot of what you call correlation. When you do a CFD with neural networks, the results come very good. What we do now is extensive amount of experimental work. And each experimental work is an expensive game. And we don't have enough wind tunnels in India. We have to go abroad. When you go abroad, he knows what we are doing. Whether you go to Russia, you go to France, or you go to USA, he knows everything about us. That is the disadvantage we have. But with this process, we have done fantastic. If you can see the just simple computation fluid dynamics doesn't work. If you do with this, what you call the INN, then it gives excellent results. And that is what we are applying now. The new aircraft which we are building called LCA-Bach-2, we use this technology. What we do, this is an important thing. You do neural networks, numerical methods, superimposed by physics. The physics will, whatever data, if the data is wrong, the physics will say this data is wrong. You just eliminate data. So what we call physics-informed node, PIN, physics-informed nodal networks. That is the key. Okay? You are introducing the Navier-Stokes equation, all the physics, and seeing that what comes out is a data which has been corrected for being in tune with the physics of the problem, and then do that. This is a very beautiful piece of work that has been done. You can see the feature neural net in an alternative to conventional computational fluid. It's a beautiful technology and doing pretty well there. Now, I will talk to you about what you call, nowadays we talk on unmanned air vehicles, this, that, and all. Let me talk to you. A subject called electronic pilot. It is the onboard computer which works like a pilot. Okay? This is a very interesting area. We have seen the light combat aircraft. We have done today a single-seat Air Force, double two-seat Air Force. We also done a naval aircraft who takes off lands from a naval carrier. Okay, all of them there. Now, the government in year 2022 has given a clearance to make an advanced version of LCA Mark 1. We call it Mark 2. It carries twice the payload of LCA. Okay, it carries twice. A very formidable aircraft. It will replace the MiG-29 aircraft, the Mirage 2000 aircraft, and the Jaguar aircraft. It will replace all the three, this fellow. And also government has given a clearance last year, what you call a 5th generation stealth fighter development. That fellow will replace the Rafale and Su-30. Okay? My hope is in the next 15 years, Indian Air Force will have only indigenous aircraft. Fighters will be there. And that's what we are looking forward to. So what are the technologies? Key technology. Stealth. I already talked about you. You have to have a very advanced sensor suite. Your radars, EWs, everything. You have to have that one. Then a fellow, an onboard fellow, who takes all the data, does all the pre-processing, and tells the pilot what he should do. Okay? I will show you one slide, what all jobs a pilot there has to do. And optional manning and automatic takeoff and landing. That is what is required. Plus, you have heard now, manned, unmanned teaming. A one manned aircraft can control 10 unmanned aircraft. And they have most of the autonomy, except he has to just give a go ahead and hit. Okay, that's all, as required. So these are the sixth generation technology, fifth plus sixth. Okay, all of them we are planning to use on fifth, but extension to the sixth. What is the way you have had today aircraft? When aircraft enters into service, you do into a territory air-to-air combat. We didn't have to do that because none of the aircraft, they only sent drones and all, missiles and all, so wasn't there. When we suppress the enemy air defense, you send you have sent Rafale and all you have done. You strike into the airfields there. You also do reconnaissance, and you support your own army. This is the functions of a fighter. This is the functions of a fighter. So, we say pilot aircraft interaction. OODA means observe, orient, decide, act. These are the four jobs it is there. You call OODA. Okay. It's a very pilot language, pilot. So what is that? The sensors are there, cockpit tactical situation displays, self-protection systems, head-up display, head-down displays. For example, head-up display of LCA was developed by one of your labs, CSO Chandigarh. They have developed the aircraft. Okay. Then we do the observation monitoring. We do the situation assessment, decision making, and action. Action is what? You fire a missile, you fire a bomb, you fire whatever is a rocket or anyone, or a gun and all. You have what you call flight controls, sensor controls, and weapons. This is the control we need to do. The real world entities. This is the mission. What I showed you is the mission. Well, just to, why do you need a pilot? Fellows have been flying for World War I onwards. Rules of engagement, manage the wingman, avoid hitting something, radio chatter, RW audio, missile warnings. Is this my target? You should know. You have a radar track, IRST track, RW track, data link track. Which one? Which one I should do? Which is the right thing? And threats, which are, is it a bullet, is it the missile, is it radiation, contamination? So you need somebody who can assist the pilot, and that is what you need, so that he first survives and then accomplishes his mission. So now it has become very clear. The complexity of the war is so high that you need someone to support him. Okay? If it is unmanned, it has to be built into the system. That's what you call artificial intelligence. So the electronic pilot does all these things. All these things. And finally, he informs the pilot what to do and all that. But final decision, I just wanted to show this one. In your own territory, you do a takeoff and cruise, but all other jobs, tactical air you do. Then again, you come back and land there. Okay? So these are the electronic pilot modules. Synthetic vision, dynamic planning, auto target recognition, target identification, situation analysis, okay? Then MSDF, EW decision support, dynamic planner, synthetic vision, collision avoidance. All these things have to be done there. Okay? Previously, the situation was a little more benign, so a pilot was able to do. But today, with the kind of scenario where we have, you also have to see whether a drone is coming, a missile is coming, or aircraft is coming. All that you have to look at it. Okay? This is what we do. Now, AI, these are the things, what I put in green. These are the artificial intelligence. These are the fellows who can help in algorithms for artificial intelligence. Quite a few. You can see sensor management, all those kind of things we can do. So what is important is for everything to do, information has to be fused. And you have, and sometimes enough information fuse is not done, hundreds of displays will be there about the targets, and it's cluttered so much, the pilot will not be able to do what he's supposed to do. And that is what the problem that occurs. So automatic target recognition system, one of the key functions of what you call electronic pilot. This is one of the key jobs. He will inform. Suppose there are 100 displays are there, he can synthesize and say, following 3 are the only ones you should do. Baki nikalo. Okay? That's what will happen. This is what that fellow does. And dynamic route plan. As you are going, you will find suddenly there is enemy threat is there. So you change the route so that there is a minimum threat that is there. Again, an electronic pilot, an artificial AI pilot, he will help you to do that. That's what will happen. And all these things, if you have seen, India was able to penetrate, had what you call electronic warfare equipment. They have jammed the air defense system of Pakistan. They totally jammed it. So the radars couldn't do anything. If the radar cannot see, missile cannot be fired. And these fellows happily and came back. So this electronic warfare system, this is a big fellow. And this is what will tell you how safely you can enter into and do the job. And this is exactly what has been done. Our people were able to, using AI, they were able to find out what is that slot where the radar cannot find. And then you go inside. And that's what they have done. Okay? That's what. These are the identification. You have to identify first. These are the ways the identification done. Okay? Some, as we are going very, very low speeds. You can have a ground collision. How do you avoid that? That also this fellow will. Earlier, the pilot used to be looking like that, whether he will avoid ground or he will fight the enemy. That was the problem. And today, this AI fellow can help you to do that. Okay? And now, last 2-3 years, the thing is, not all manned aircraft can go. It's expensive. You lose your pilot. You don't want to go. You can send unmanned vehicles. Now, today, they send a lot of cheap drones. But you want to send something which can do the job. They have, internally, they have got an artificial intelligence. But they are linked with the data link to a manned fellow who is sitting up. And they were able to look at it. And this manned-unmanned teaming is the 6th generation technology. And this is a critical technology where AI becomes a big part of success of this program. And that's what it's doing. So we have reached a crucial moment where using AI is not just a choice, but a necessity to stay globally competitively, not only competitively, for your survival also. Okay. Today it is no longer a choice, and I used to have and all. I think we have reached a stage, has to be used, has to be learned, has to be taught. And that's what it needs to be done. So, sir, thank you very much. I think I bored you sufficiently. I think you can come back, sir. Here.
Thank you so much, sir. It's always a privilege to have you here, sir, be it stealth technology or enlightening us regarding the role of emerging technologies like artificial intelligence in agriculture, aviation, aircraft designing. We are very much thankful to you, sir, for sharing your insights with us. Now I request Professor Damodar Acharya, sir, former Director IIT Kharagpur and Chairman INA BBS chapter, to say a few words.
Jai Jagannath. So very good afternoon to all of you who are present here, both physically as well as many virtually. So here we have the most respected and very dynamic young fellow of 82 years old, that is Dr. Kota Harinarayan. Age-wise he is senior most, but he is actually mentally and physically everything, he is much younger than all of us present here. Okay. Then of course we have our director, Dr. Ramanuj Narayan. We have young friend Subhrangshu, also still younger friend. That is Dr. Jena, and many senior fellows who are present here, scientists and students present in this hall. Actually, you may be wondering that why actually I came here. The very purpose is I wanted to say something about this National Technology Day that we are celebrating here, and why actually we are doing in this fashion. First of all, as it has been told, that INA Bhubaneswar chapter is the most active chapter, and lot of things actually they have done. And it is not actually this INA Bhubaneswar chapter, it is a virtual thing, nothing is there. It has got no resources, nothing of that sort. All these things have been done with actually collaboration of many institutions, prominent institutions of this place, that is Bhubaneswar, that they include Sikha Anusandhan University, where just I happen to sit there, and they do provide some facilities, plus IIT Bhubaneswar, IMMT Bhubaneswar, NISER Bhubaneswar. Also, we have other institutions like ICT, IOC campus in Bhubaneswar. Then very active and dynamic, IEEE Bhubaneswar section. Lot of people are there in that, from that side. There are many fellows from that also. So with all their support, something actually we are able to do. Now, when INA really told us that you have to conduct this National Technology Day in a befitting manner, so we thought actually that why not to do these things not just at one place but in our partner institutions in 4 different places. And the speakers, distinguished speakers that we choose, we didn't know at that point of time. First of all, we thought that the first man will be actually should be somebody from BARC, because it is there the Pokhran blast actually that we are celebrating. And fortunately, the BARC Atomic Energy Commission chairman that time actually agreed, but due to some reason actually he couldn't come. But we had this Dr. A.K. Tyagi, very, very dynamic and one of the most celebrated actually scientists that we have, and who happens to be the first Vigyan Shri awardee, that is equivalent to Padma Shri awardee. Here on, last Saturday, and it was a wonderful lecture by him, which told not only about nuclear technology, what they are doing, but its applications to varieties of field, what is actually being done. It was not to my knowledge, but it was really a great lecture. The second one, definitely what we have talked about is that whatever that we have seen, we have not actually visualized earlier, but we choose those people who are actually responsible for the whatever success that we have got in recent conflict that we had with Pakistan. And the second one actually we have to choose about our aircraft, and actually the like our light combat aircraft and other unmanned vehicles, whatever wonders they have done. So to celebrate them, we got actually Dr. Kota Harinarayan, who could be a better person to actually give us some ideas. And fortunately, he has actually spoken in so many other things, apart from actually the aircraft design, but that also we didn't have much of idea. It was again an excellent lecture. The third one that we are going to have in this whole operation, one of the information which has been really provided by, and correct information which has been provided by, is by our geostationary satellites. And then these geostationary satellites is actually brainchild and creation of actually our ISRO. So the third lecture actually we are going to have is by chairman of ISRO, Dr. V. Narayanan, and it will be there in NISER Bhubaneswar campus on 21st. And fourth one will be by DRDO DG, and who have really played very, very important role in this conflict, whether it is related to the communication system or it is actually related to our firepower and all these things. So he will give actually some, glimpse on this thing. I'm really so excited and happy that we didn't know about all these things, but we have chosen the areas and the speakers, keeping actually this thing which we found to be very, very useful in recent conflict. Thank you very much. I don't want to take much of your time.
Thank you, sir. Let us now take a moment to felicitate our chief guest. I request our director, sir, and Professor Damodar Acharya, sir, to kindly do the honors. This is from INA Bhubaneswar chapter. This is from CSIR IMMT Bhubaneswar. Thank you, sirs. Now, every successful event is a sum of many efforts. I now invite Dr. Mamta Mahapatra, Senior Principal Scientist, Department of Hydro, Bio and Electrometallurgy, CSIR IMMT, to deliver the vote of thanks and express our gratitude to everyone. Sorry, if anyone has any queries or questions to ask to sir.
I agreed to answer questions because I can't answer all the professors.
Yes, sir.
Answer. Student hai.
No, I thought your lecture was so precisely, no questions are necessary.
Okay, I request Dr. Mamta ma'am to kindly deliver the vote of thanks.
Yeah. Thank you, all my colleagues be here. A very good afternoon to everyone present over here. It is both an honor and privilege for me to deliver the vote of thanks on National Technology Day 2025, a day that commemorates not only India's technological achievements but also inspire us to push the boundaries of innovation, research and sustainable development. On behalf of the organizing committee, I extend my heartfelt gratitude to our Honorable Chief Guest, Sir Padma Shri Dr. Kota Harinarayan Sir, for gracing this event with an inspiring presence and delivering a talk which will nurture all of us, not only scientific, technologically also. So I thank you, sir, from my core of the heart to give such a wonderful talk. And lot of if you see the talk is how much humorously he is presenting and how we are enjoying the talk. That shows his interest in the subject. So we all are thankful for that. Your words have reinforced our collective resolve to harness technology for inclusive growth and national progress. I would like to take this opportunity to convey our deep sense of gratitude to our director, sir, whose visionary leadership, constant encouragement and unwavering support have been instrumental in the successful organization of these events. I also express sincere thanks to INE and INE Bhubaneswar chapter chairman, sir, Professor Acharya sir, and Professor Subhranshu Ranjan Samantraya sir, to give and to thought ki IMMT will be the best place for this talk. So we from the IMMT, on behalf of IMMT, I am thankful, sir, to give the opportunity to our institute to arrange this talk. And a special word of appreciation to all our head of the department, our leadership group, finance and purchase department, administrative staff, scientists, students and contractual staffs, and all our press and organizers of media. We also immensely grateful to our institutional partner, Indian National Academy of Engineering, Niger, SOA University, ICT BBSR, IIT Bhubaneswar, IIA Bhubaneswar section, whose generous support made this event possible. Your continued faith in academic and technological endeavors is commendable. A warm thanks to organizing committee and volunteers who worked tirelessly behind the scene with admirable dedications. So lastly, I extend my heartfelt thanks to our technical team for ensuring flawless coverage and communication throughout the day. Let us carry forward the momentum and inspiration of today as we commit ourselves in building technological empowered, innovative and self-reliant India. So thank you all, and I request all of you to have some light refreshment outside. So with this, I am also requesting all, please come and arrange yourself so that we will take a group photo. Huh? First, okay. First we will go for national anthem. Then we will take the group photo.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
So we'll have a group photo, please. We can go like this. Sir,